Results: proliferation of cells in the depleted culture medium. The first investigations in the regulation of cell division were carried out in vitro with animal cell cultures MCF7 of 4. For 116b15, we found that in a medium of lower than natural D content, cell division started after a delay of 5 to 10 hours. The medium of a decreased D content, however, only had a minimal effect on subsequent growth. Results reveal that cells recognize the lack of deuterium but quickly adapt themselves to the new medium. This also shows that the stoppage or slowing of cell division is caused by the difference in the concentration. When the cells were exposed to a DD water medium for several hours, the difference between the control and the DD water culture medium decreased significantly. Our results were later reinforced by investigations carried out in the laboratories of Oneotech Incorporation in Irvine, California. In the first series of experiments, scientists followed the incorporation of H-thymidine into DNA after the change of medium in PC3 prostate, MCF7 breast, and 4 megaliters melanoma cell lines. Following deuterium depletion, inhibition was experienced in all cell lines. It is important to note that the sensitivity of cell lines was different, manifesting itself in the fact that, in the case of melanoma cell lines, inhibition was maintained for 6 hours only, in prostate cell lines for 21 hours. In the case of breast cell lines, inhibition lasted for 48 hours. In all cases, inhibition was stronger when cells synchronized in Golgi phase were exposed to DD water culture medium. The rate of inhibition was around 20%. In the above cases, cells were exposed to a decrease in the concentration on one occasion only. For modeling the process in the human body, which means a decrease in the concentration lasting for several months and occurring daily, we later had experiments carried out in the course of which the deconcentration of the culture medium was decreased not in a single step, but in 2 to 5 steps: 1506055514612 ppm within 21 to 72 hours. These experiments were carried out in vitro with freshly removed human breast and ovary tumors. Results showed that the more the deconcentration was decreased, the greater the inhibitory effect, reaching, at the end of the 3rd day, a value of 40%. This modeled experiment clearly demonstrates that with the continuous decrease of D level, the inhibition of cell division can not only be maintained for a longer time but can also be increased. We later demonstrated that the proliferation of the HE29 human colon tumor cell line could also be inhibited in a DD water medium. We wish to stress that in a healthy myometrial cell line examined simultaneously, the DD water medium only slightly influenced the proliferation rate of cells. Experiments WIDII mice WIDII transplanted human tumors, as in vitro experiments showed that in a DD water medium, cell proliferation starts with a delay and that by a multiple decrease in the concentration inhibition can even be increased. We set off to examine the effect of DD water on the growth of human tumors transplanted into mice. The first experiment was carried out with 2 different breast cell lines MDA, MCF7. The animals were treated with 30 ppm DD water the day following transplantation. 3 months later, from the 11.5+6 tumorous animals in the 2 control groups, only 1 survived. Its tumor had spontaneously regressed, whereas in the treated groups, from 17 9+8 tumorous animals, initial tumor growth stopped in 11, followed by total regression 11. In 2 further independent investigations with mice, the effects of DD water on PC3 human prostate tumors were examined. In the first experiment with prostate tumors, the treatment Of the animals, 22 in the control group and 22 in the treated group started on the 32nd day after transplantation. The average tumor volumes were 1.2 cm in both groups. In lying and advanced state, tumor growth was then followed individually in the animals, and we found that in the control group the tumor size gradually increased in every animal except one. In the treated group, the tumor volumes were found to increase continuously in only 8 of the animals, where the size of the tumor had been above average. In 7 animals with near to average tumor volume, initial tumor regression was observed, and it was only after 1 to 2 weeks that tumor volume started to increase. From 7 further animals with smaller tumors, 0.1, 0.2 cm3 exhibited complete tumor regression, while in one case tumor growth was completely inhibited for 2 to 4 weeks. 16. Inhibition is well reflected by the fact that in the control group, the average value of tumor volume was 11 centimeters on the 74th day of treatment. In the group treated with DD water, this number was a mere 1.3 centimeters. In the second experiment, we repeated the one carried out with PC3 prostate tumors, this time investigating the anti-cancer effect of DD water on a cellular level. Following transplantation, both groups were given normal water for 18 days to allow the tumor time to develop. After this, the treated group consumed DD water for 2 weeks, and then all animals were killed. The inhibitory effect of DD water was evident macroscopically, the average tumor volume being 40% smaller. But of more importance was the fact that the tumors in the treated group were almost regular, ball-shaped ones, whereas in the control group they were grown difficulty. Microscopic investigation of the frequency of cells in mitosis dividing and apoptosis dying revealed the following results. 15, 16, Table 11. 1. Deuterium depiction inhibited cell division and triggered apoptosis in vitro. These investigations corroborated the finding that D-depletion causes cell death. Investigation into the anti-cancer effect of deuterium depletion in dogs and cats. Results are presented through the description of 3 actual cases with the help of a summarizing table. Table 11. 2. Case history. 1. A cat in very poor condition was taken to the veterinary hospital. It was weak and had no appetite. Body mass 4 kilograms. Veterinary examination stated an apathetic animal uninterested in its surroundings, with medium degree anemia and a palpable swelling of lymphatic glands. During the physical examination of the abdominal cavity, a growth of 2x3 cm in size was palpable, corroborated by X-ray imaging. During a consequent diagnostic laparotomy, the significant swelling of the mesentery lymphatic gland and a moderate swelling of all the other glands was found. One lymphatic gland was surgically removed, and pathological examination corroborated lymphoid leukocysts. Table 11. To the effect of DD water on animal dog, cat tumors. Because of the poor overall condition of the cat, DD water was initially given 5 times a day orally with a syringe. On the 7th day of treatment, the cat could drink by itself and became lively. From this time on, its condition improved daily. It became interested in its surroundings, and on some days it was able to eat unaided. After 3 weeks of hospitalization, although the enlarged lymphatic glands were still palpable, there were other symptoms related to the primary disease. The end of the 3rd month of the treatment, a further lymphatic gland was removed, which still showed the earlier diagnosis. After a further 3 months, during the repeated pathological investigation, lymphatic hyperplasia was diagnosed. 2 years after the first diagnosis, the cat was healthy, had a good appetite, and a body mass of 9 kilograms. Case history 2. The first DD water-treated dog had a mammary tumor, the size of which was 10x6 cm at the beginning of the treatment. In addition, Several smaller metastases of 2 to 3 cm in diameter were palpable. Pathologists diagnosed it physiologically as adenocarcinoma. The consumption of DD water for 1 to 2 months led to a complete regression of the smaller metastases, accompanied by the decreasing volume of the primary tumor. After 5 months, the size of the tumor was 6x, 1 cm, and after further 4 months 3x to cm, when it was removed surgically. Case history 3. In the case of a dog with a tumor of the testis, the tumor was diagnosed as being diffuse seminoma. As an effect of DD water 90 ppm, tumor growth stopped, and although there was no regression, the size of the tumor stagnated during the several months-long treatment. Following a break in the treatment, the tumor started to grow again and repeatedly stagnated after the renewed consumption of DD water. We consider it possible that in the case of a smaller tumor size, it had originally been 5x 6 cm, or with the application of DD water of lower than 90 ppm D content, a regression could have been reached. Mention must be made of the fact that DD water of a 90 ppm D content did not prove to be effective in the case of dogs with melanoma. 3 such dogs have been treated so far with no genuine improvement. In the case of this tumor type, treatment should be attempted with a VTR-ADDW25 mixture of a 72 or 65 ppm concentration, see appendix, and the dose should be increased within a month. Our observations are in harmony with the in vitro results of Oncotech Incorporated, where it was shown that the melanoma cell line had adapted to the culture media with a decreased D content 6 hours after the exposition. Whereas in the case of prostate and breast cell lines, this happened only after 24 to 48 hours.